Hello friends, welcome to Hadoop Big Data Tutorial.com powered by Wisdom Trainings. Here I'll be taking you through the free videos of Hadoop developer course. Right, so I'll just go to the website. So under the website Hadoop Big Data Tutorial.com, there's a tab Hadoop developer free videos which you can refer. And for this particular video, you have to go under the section Advanced MapReduce, right? And you have to click on the very first link here, that is Advanced MapReduce Distributed Cache Part 1. So here we'll be talking about distributed cache, the concept that is available in Advanced MapReduce, right? So I'll just open up my notepad here and tell you something about distributed cache. Before I move for distributed cache, we need to understand what a cache is. In normal language, also in normal terms, in normal computers, we have a cache, right? So what does it do? So it is a component, okay, which stores the data locally so that next time when a request comes, okay, it need not have to ask the data from the website itself. So if you are accessing a particular website, for example, right, let's say abc.com, and it has certain amount of data that can be cached or that can be stored onto your local file system. So there is a component cache which will store the data for you. Okay, so when next time when you try to access that abc.txt, so your accessing will become more faster because of the already present data locally on your system, right? So in this way it increases the efficiency, or it increases the usage of network. Okay, so in this way you are able to get the response much faster than if it's not cached, right? Okay, now coming on to the distributed cache here. Okay, so this is a similar concept that is provided by Hadoop MapReduce framework to us, right? So let me just annotate it and tell it to you. Hold on. Okay, yeah, so you have your master nodes here, right? You have your slave nodes. So I have one master and I have several slaves here. So this is my master node, and here comes my slave 1, right? And this is my slave 2, and here goes slave 3, and so on. This is my slave 4, right? So what distributed cache is, so you store a certain cache file here. Let's say this is my cache file which is on my HDFS here. So I'm naming it as abc.txt. let's say it is a txt file, the file which is required when you're running a job. So once you run a job, this txt file will be copied onto each slave, okay, and it is made available locally onto the slaves. So it is made available locally to the slave nodes. Alright, so it is already present on HDFS. You have to copy once onto your HDFS, and once you run a job, so once you run a job here, the cache files will be copied onto the slave nodes and will act as if they're local to the slave, right? So this is the very major advantage. So here not only the text file you can cache here your archives, okay, your jar files which are required by the applications. So these can be cached. Okay, so archives jars can be cached which are required by the application. Alright, so this is a concept of distributed cache that is provided with the MapReduce framework itself. Alright, so we'll be seeing the hands-on part of this as well. So I have a problem statement with me that we'll be talking about, okay, and we'll see how to cache a file and what all things can be done. So I'll talk about the problem statement right away. Okay, so let me just do away with the annotation here. So I'm gonna write the problem statement here. Okay, so the problem statement is using distributed cache, we have to, in MapReduce, we need to find the byte offset values of the words of the matching keywords. In the news archives. Okay, so I have a certain data set with me, and I'll make a certain file that I'll be caching on. I have a data set. Hold on, let me just annotate and tell it to you. So I'll be having a data set here. Let's say this is my news archive. Okay, and I'll be having a file which I'll be putting in my HDFS as a cache file. So this is my HDFS, right? And I'm gonna use here a file which will be a keywords file. Okay, so what all keywords would be there in this cache file? So this is my distributed cache file. Okay, hold on. Okay, so this, while running a job, I'll make a jar file to run the job. So job will refer these keywords. Okay, and what it'll do is it'll find what all keywords are present in the cache file, and it'll look for those keywords in the news archive here. Okay, and it will give you the byte offset values of wherever that keyword is occurring. For example, let's say I'm searching for a keyword here. I have certain keywords I'm going to write here: Hadoop and big data, learning, wisdom, trainings. Okay, and let's say this is not a news archive, this is an article in the newspaper about big data. Okay, so it'll, this job, the job that will be running, will be writing the code and will run the job. It will see that these all are the keywords that are present in the cache file. It will refer this keywords. Okay, so it will refer these keywords and will try to search for the keywords in the newspaper article. Fine, and wherever it is finding that keyword particular, it will give you in return. So output of the job will be byte offset value plus the keyword. For example, I have a paragraph here. Let's say Hadoop is fun, come and learn Hadoop with wisdom trainings, right? So the byte offset value is from where the line is getting started, and each increasing the what all characters are present, it will keep on increasing. For example, so Hadoop is my first line, so its byte offset value will be 0 here. Okay, for H, right? So if we talk about every character increases the byte here, so it will find that Hadoop is present on 0. Okay, and moreover Hadoop is present on some, I'm just taking it a random number, this one, I'm assuming that this is something, for example 20. Okay, so this all characters are consuming 20 bytes, and the next keyword Hadoop is present on 20th location, that is 20th is the byte offset value of that word. Alright, so similarly it will search for every keyword that is present inside the cache file, right, and it will look for that in the newspaper article or the news archive. Alright, so let me show you the data set as well. For that, I'm just going on to my virtual machine. So I'm using here the Cloudera virtual machine that I have already explained in the paid videos. So for that you need to buy the course. Okay, so we are using the Cloudera virtual machine, and I'm gonna take you through the data set that is available that we'll be working on. So I have these news keywords which I'll be caching. So I am putting the values university, Africa, Antarctica, health quest, nanoparticles, Hubble, and leukemia. Alright, and I have the data set on which I'll be running the job. So this is a article about science and all. So it will have certain words, university or leukemia or what all words will be there, and not certainly all words would be there, but I have just picked up there might be certain words which are already present in the science.txt. So it will look for that word and give you in return the byte offset value along with the keyword, right? So this is our data set. So we'll be putting this file onto our cache distributed cache. Okay, and then we'll be running the job on our this data set. Alright, so for that I just need to go to the Eclipse for my hands-on part, right? So let's go to Eclipse. Okay, alright, this is my Eclipse ID, right? So I'll create a new project here. I'm gonna name it as distributed cache. Alright, click on next and finish. So the project is created successfully now. Next step is we need to add a package here. So go to source. Okay, right click there. Hold on, sorry. Right click here and click on new, go to package. Okay, I'm gonna name my package as com.distributed cache, right? And I'll click on finish. So my distributed cache package is created successfully. Now what we need to do is we need to have a class file, sorry, a class. So I'll right click there, click on new and click on class. I'm gonna name it as matching words job, right? And I'll include my main method as well. I click on finish, right? Hold on. Okay, so my package and my class is created. So before we move further, I need to add the Hadoop libraries or the jar files. So I'll go to my project, right click there and go to build path. Under build path I have something called as configured build path, and I'll click on libraries, add external jars. So my jars are present under you have to go to Cloudera. Alright, and then under Cloudera you have there's a directory called as, hold on, so you have to go to file system and then you have to go to user jars. Okay, so these are the jar files that are available for your Hadoop ecosystem. So under user slash user slash jars, right? So you have to click on, or you have to add Hadoop. So this is the jar file Hadoop 2.6.0 cdh plus another jar file client core. Okay, so this one and the top one, that is Hadoop, hold on, Hadoop common and Hadoop client core. Alright, click on OK and again OK. So you can see the reference libraries added here in the reference library section. Okay, now we need to our class needs to extend the configured class and it should implement the tool interface. Right, so I'll just hover over this and add the classes required for it. So this is input tool, that is Apache Hadoop util, and for configured you need to import this. Okay, so you need to add the unimplemented methods of the interface, that is run method. Okay, so this is the method you need to implement. Okay, so before we write the main function and we write the run, we need to implement our mapper class. Alright, so what I'll do is I write here, hold on, so we were talking about the mapper class, right? So before we write up our mapper class, I'll just take you through the slides even. Okay, so I'll go back and walk you through the slides that are available with us. So distributed cache, and I already told you that MapReduce framework, which is used to cache the files which are required by the applications. So text files, archives and jars can be cached, right? And we may require to share some files across all the nodes. As I told you that we need to have we will keep it on our HDFS and we'll be transferring it onto our slave nodes. Okay, so you can specify the URLs using HTTP or HDFS, and they have to be cached by job conf. We'll be talking about this stuff as well. Okay, so before we need to copy that onto our file system, and then it can be cached. So the one-time process is to copy the file onto our HDFS, and then it can be cached onto our subsequent slave nodes. Fine. Okay, this is something written. The framework will copy the necessary files onto our slave nodes before any task or jobs are executed. And distributed cache can be used to distribute simple read-only data, and all this we already talked about, archives and jars. Okay, so another thing that you need to make sure that cache files should not be modified by the application or externally while the job is executing. So this can hamper the job. So that can be a failure if somebody, or by mistake, if it is hampered. Okay, because already the job is running, and in between, if a cache file, if something goes wrong with the cache file, your job will fail, right? So we need to make sure that in distributed cache, what all files are present there should remain intact, right? So how do we set up the cache for the application? We need to copy the requisite files onto our HDFS and set up the application's job conf. So we need to use the cached files in the mapper or reducer. Alright, now going back onto our, so you can either use the cache files in the mapper or the reducer. So here in our case we'll be using the mapper. You can also do it through the reducer. So in our case we are only doing it with the mapper, right? So I'll go back to the virtual machine, that is Cloudera VM, right? And I'll write my mapper class. So here we go. I write here public static class. I'm gonna give it a name to my mapper class as line mapper. Okay, so this class will extend my mapper class, which is already present in MapReduce. So this is the one. Okay, so it has 4 set of parameters, that is key in, value in, key out and value out. The first two are referring to the key value pair of the input of the mapper, and the rest two are referring to the output of the mapper, that is key and value. Okay, so here this should be of type long writable, that is the key in should be of long writable, and the value should be of text. Alright, similarly key out should be of long writable, and value out should be of text type. Alright, and this is my class now. Okay, so I'm making a class inside class, so I'm declaring my line mapper class as static. Alright, now there are two important things that we need to have in the mapper class, that is two very important member variables, I must say. that is a space pattern, and the other thing we need to have is a hash set. Okay, so space pattern is required. It will read the line and it will from the data set, and it will compile them on the basis of a delimiter, for example a space. So it will split the line into tokens. So for example, you have a line here, Hadoop is fun, or Hadoop learning made easy. So it will divide that line into different words, that is Hadoop is one word, then is another word, learning is another word. So this way it will have certain words aligned. Okay, so I'll declare this private, okay, and pattern, I'm gonna give it name as space pattern, is equal to pattern dot compile on the basis of a space, right? Okay, so here we have written the space pattern. Now it's time for us to declare a hash set. So what it'll do is it will pick up the keywords that we have defined. So these are the keywords, right? So there can be other keywords which are not unique, or means they can be redundant keywords as well. So hash set will help us identify only the unique keywords. Okay, here there is no there is no redundant keyword here, all are unique here. But in case you have if your redundant keywords, so hash set will take only the unique values and will keep it in up. So it's this thing hash set we have covered in the collections part of Java module, right? So I'm gonna declare hash set here, private set. I need to specify it's of type string and give it a name as keywords is equal to new hash set, right, string. Okay, so my hash set is defined successfully. I just need to add this. Yeah, so you need to import Java util classes. For collections you need to import all the classes of Java util, right? Okay, and now what we'll do is we'll have the overridden methods in our mapper class. We have two overridden methods here. One is the setup method and other one is the map method itself. Alright, so we'll have to override those methods here. So I'll write here setup and right. So this is the overridden method. I'll just pick up the super dot setup, otherwise it will call the method of the super class. Now I'll declare my own stuff here. So I need to have a array of URI, that is uniform resource identifier, which will be used to fetch the files from distributed cache. So I write here URIs is equal to distributed cache dot get cache files, right? And I write here context dot get configuration. So this way we are writing the URI, and just import this, right? Okay, so now we need to take the instance of file system, so which will with the help of which we'll copy the file from our HDFS to local file system. So I'll write here file system fs is equal to file system dot get context dot get configuration. Alright, so we have declared the instance of file system class. Now we need to check if the array that we've got from distributed cache, whether it has some file or not. So if it doesn't have file, we need to throw an error over there. So I write here if URIs is equal to null, or okay, URIs dot length is equal to 0, right? Then it should enter this condition and throw an IO exception, which should be error reading files from distributed cache. Alright, I'll add this. Let's throw new IO exception, right? Okay. Else, if it is not the case, if there are files present, then we'll declare a variable local path of type string, and this is a path where we'll be storing our file on local file system. So I'll write here dot slash keywords dot txt. Okay, and now it's done for us to copy the file from HDFS to local file system. So we have already declared the instance of file system class. So using that, fs dot copy to local. Okay, so copy to local file, and you need to specify the source and the destination. So the source here would be new path URIs, and destination would be local path here. So what all files would be present in the distributed cache, it is gonna store in the array URIs, okay, and on the 0th index, and the destination here is the local path that is on HDFS. Sorry, and that is on the this is on the local file system, and this one corresponds to the path where our cache files would be actually present on HDFS, right? Alright, actually I have to specify here new path local. Right. Okay, so this will copy the file from HDFS to local file system, and now what we need to do is we need to read that file, read the file which we have got, right? So for that I will use buffered reader. So we talk about buffered reader here. Okay, so buffered reader is equal to, I'll write new buffered reader, and from where it should read? It should read from the local file path. So let here new file reader, and the name of the file from where it should read local path. So with the help of buffer reader you can actually read the file. So once you have read the file, we need to have the words taken out of them and then put it into keyword, right? So this is the file which have all the keywords. So we'll read the file, we'll extract the words, and then we'll put it into the hash set. So for that, what you need to do is write here string word is equal to null. Okay, and I'll make a while loop here. While word is equal to reader dot read line, right, is not equal to null, then it should enter this condition, or sorry, inside the loop. Okay, so once it is equal to null, it should not get inside. So if it is getting to read something, then it should get inside this loop. Okay, and what it should do, it should add the values keywords dot add the word. right? So for example, you have certain keywords, right? You have hello, you have Hadoop, you have let's say university and all. So it will read that word line one by one and then put it into keywords here. So one by one. All right. Now, so we are done with our setup method. Now we need to override the our map method. Okay. So this is my setup method. So which is here. Okay. So I'll override the map method as well. Okay, so I'll just remove this key line super, otherwise it will call the method which is in super class, right? And now for this we need to write here, I'll declare a array of string class. Okay, I write here at tokens is equal to space pattern dot, it should split on the basis of a value. Okay, so split on the basis of value to dot string. So we have already defined that space pattern is splitting the line on the basis of space, right? So here what all parameters, the values you will be getting from, or the lines you'll be getting, so to split that on the basis of space and then put it into tokens array, right? And then we'll have a for loop, so which will iterate through the tokens array, and I'll write here string token. If it lies in the tokens, it should enter the loop. Hold on, I just need to enter, right? Okay, yeah. So then what it should do, it should check if keywords dot contains the token itself, then it should enter this condition and then write on the output. So context dot write. So you have two methods of writing the output in MapReduce. One is the output collector and the other one is context dot write. Okay, so I'm using here context dot write. I'll pass here the key. So I want that my key should be printed along with the, that is my byte offset value, along with my token. Alright, so this was about the mapper class. So rest of the code I'm gonna share it with you in the second video, right? So for that you'll have to go back to your website and click on the second video part, that is advanced MapReduce distributed cache part 2. Alright, thanks.